Greetings and welcome to the Pure Report. I'm your host, Rob Ludeman, and it is time to bring the orange. And I am thrilled to have in studio today Robert Alvarez, solution architect. Am I getting your title right? You're going to roll with that, working on AI and AI labs. Great to have you in. Thanks for coming in today.
Thanks, Rob.
Yeah, it's great. We're long overdue, I think.
Yeah, it's been a while.
Partly just because I've known you for a while here and you know so much about AI, but I think this marks, as you were telling me before the program, this is the first time we've had two Robs.
Yeah.
So everybody enjoy that. Enjoy the two Robs. Tell us how long you've been here at Pure and what you've been up to.
I've been at Pure for 2 years. In those 2 years, I've been designing and building reference architectures out with our partners, so NVIDIA, Cisco, and many others that I'll probably not mention, but they're all very valuable. But we're trying to think about, like, how do we build out AI workloads and AI pipelines, and how do we make sure that Pure Storage is the leader in making sure that those AI workloads is fed as good as possible, but also do some innovation.
Right.
Like, even if it's just saying like Pure Storage works, that's also important. But we need to get our field thinking about how to talk to customers about AI. What are the things that are happening in the AI field, and how they can position themselves to be in the conversation instead of always deferring to a partner or someone else to be like, no, we've got AI knowledge too, and we know exactly what it is that you're talking about, and here's where we fit in that solution.
Yeah, it's challenging because there are a number of things that happen at the ecosystem level, and then we come in and go, well, we're the store. We can manage your data really well, but as we've seen over the last couple of years, you and many other really super smart people, which I want to get into in a sec, have come in and said, no, there's things that we can actually do down at the storage layer that are innovative. And complementary with our partners, because it is yes and right, a kind of approach, which is super exciting. And we are going to get into, like, this episode is all going to be around Pure KVA, the key value accelerator, KB caching, we sometimes refer to it. But tell us a little bit more about you. Like, you're super credible. I went through your bio on LinkedIn and I was kind of blown away. Like, professor at Santa Clara University, worked at NASA. You've got some good chops. You've done a lot of interesting stuff, and it kind of sounded like it all started with a love of mathematics.
Correct.
Right?
So I always knew that I wanted to study math. Actually, I didn't know that math was a career. It was just like I was good at math.
You didn't know you could be an actuary?
I did, well,
maybe. That's one extreme.
But
right?
It was like, I like math. So I went to my first college math professor. I was like, I know that I'm technically an engineering major, but how do I just do more math?
Yeah.
And she was like, you could just become a math major. And I was like, that's a thing. So immediately, like, changed my registration at the dean's office and was like, I am now officially a math major, and went down that route, studied physics, was debating between a PhD in physics and a PhD in math.
Okay.
Ended up choosing what I think is the right option. I went with biomathematics. I had always been really good at math, and I was good at physics because I was good at math. And then my PhD dissertation was focused on mathematical modeling of infectious diseases and cancer. So how do we use mathematical models to get insight into how we can find new methods of attack or how diseases will spread within hosts and also within populations. So my colleagues from grad school did a lot of research on COVID. I was already at that point in the machine learning space.
Yeah. But super credible. That's why I am thrilled to have you on. One other part of your LinkedIn bio that I couldn't let go by, pineapple on pizza eater. So you weren't expecting that. I just threw that in because my son is also a pineapple on pizza eating lover. And his football coaches always used to give him so much grief about it because they would go out and get pizza after games and he would do the pineapple.
I have been the one person who, like, at a pizza party would be like, hey, we should order pineapple pizza. And they were like, oh, it's gross. But it's just a fun, like, when you, on LinkedIn specifically, it's very hard to convey how you are as a person.
Yeah, character.
And like, because it's supposed to be someone I want to work with.
Quirkiness just something that it stands out too.
Yeah, the amount of people who have messaged me after seeing my LinkedIn and been like, I hate pineapple on pizza, but I enjoy that you put it on there, or vice versa. I love pineapple on pizza. So it's just a good conversation starter because there's also sometimes can be intimidating things of like NASA, professor, PhD that just like, look, I'm a regular person.
Yeah, it softens it for you.
Yeah.
Okay, now we can go into machine learning and other things.
Yeah.
Right? Yeah. But what was that shift for you, right? You were hitting math, the physics, the modeling around cancer. And then all of a sudden it's like, okay, what about all of a sudden it's data.
Correct.
and it was analytics. Like, how did that shift happen that got you so passionate around that?
It was more of a refocusing of an existing skill set.
Okay.
So when I think of all of the classes that I took in grad school, linear algebra, partial differential equations, etc., calculus, and you think about what are the actual tools that are underpinning machine learning algorithms, decision science, Monte Carlo methods, etc., they all have a very strong mathematical foundation. And I've always prided myself on my communication skills and how I can take something that's actually quite complex and break it down in a way that is easy to digest.
Your translation mechanism,
Yeah.
basically.
But my foundation of all that has always been mathematics. So there was an algorithm in data science called PCA, Principal Component Analysis. And what it does is basically says, like, you might have a lot of signals, but which are the strongest signals here? And there's a mathematical algorithm that does that. And when I looked into it, I was like, oh, that's this thing that I learned in linear algebra, singular value decomposition. And then I was like, and I've always used to explain it, I was like, if you were Victor Frankenstein and you had to come up with the most realistic looking Frankenstein, what things would you care about? And that's exactly what singular value decomposition, like, it has to physically resemble a human, but like, do you need to model cellular structure? No, you're just trying to make,
right.
But like, hair should be there. So
Sure.
these are the strong input signals that come out of a mathematical algorithm saying, like, I want to reproduce this as realistically as possible, but I don't want to use all the data available because that's too computationally intensive. We can use these algorithms to help reduce that. And those are still actually true in deep learning and machine learning and computer vision space as well.
Yeah, and a little bit related to what we're going to hit on today, coincidentally, which is great. Well, I bumped out and looked at a stat because part of what we're hitting today does relate directly to AI inferencing, right, with this KVA solution. I had no idea the projected market size for this is vast, right? Going from like 80 billion in the last 12 months to, according to this stat, and make sure I get it right, like 350 billion by 2032. So 7 years from now, just massive, massive growth. What's growing the trend? Why is that happening?
Well, obviously ChatGPT is the impetus for a lot of this, or the catalyst, I should say. But as we move away from foundational models and start doing more enterprise level workloads, that you're going to have most of them be running inference. Like, a lot of enterprises aren't going to be training their own models. They can fine tune their own models, but eventually they're going to be just running a fleet of models. Those models are going to be talking to themselves. So you have to remember that inference is also an agentic workflow. And that's where I think a lot of that growth comes from. You're going to have models talking to each other, doing business decisions, making this, or doing the analysis that is obfuscated away from the end user. It's not just the chatbot. It is doing so much more that you constantly have to be sending the signal back and forth. And that requires a lot of hardware investments, data storage investments, to make sure that those fleets are working appropriately.
And we maybe have a blind spot to that because I think we focus in on the chatbot because as consumers, it's kind of what we see the most, right? That's what's visible, but not everything else that's going on in the background.
Yeah, and if you think around, for those who have used like Claude Code or Codex or Copilot, there's now reasoning built within them, and reasoning isn't also an inference pipeline. When I send a message to Claude Code, usually it probably generates 2,000 to 3,000 tokens of reasoning, and then it gives me like 300 tokens out. But that entire pipeline was all an inference pipeline.
So that makes sense as to why the growth is happening. But so let's do the backdrop around where we're going to go with KVA here.
I was just about to get there.
Why is this hard, right? I always love for guys like you coming on the program, like, why is this hard? You just made it sound really easy. Well, you have all these models and all these, and they're going to start, communicating with one another. But these are big data sets.
These are big data sets. And if you think about, like, we're asking these models to do more and more complex things, which means that they need to either reason more or they need to have a long context to help with that business decision. A simple use case that I think most people would understand is if you have a chatbot that's a customer service router, like, it'll ask you a few questions, but based on those questions, it needs to know how to route you. So that you're going to give it a long context. But that means that these models, also in agentic workflows, but we'll stick to the customer service model for now, you're always feeding it that piece of text that says, here is how you route things. And then it says, here's the customer's question or their concern, etc. So these documents always have to be generated. So I position it to as like being in Groundhog Day. So Bill Murray lived every day, lived Groundhog Day over and over and over again.
Over and over.
These models have to process that exact same piece of text over and over and over and over again. And there are inefficiencies to that because you can use KV caching to offload that and then inject it immediately so that you don't have to spend, whether it's half a second or a full second or 2 seconds, depending on very, very long context. This could actually be multiple seconds that all it's doing is computing the very first word it's going to spit out. And it has to do that. And then you're like, wait, but I've already used those compute cycles. How do I gain efficiencies there?
Yeah. And so that's at the heart of it. Well, explain it. So you're heading that direction for us already. So at the heart, how would you describe, maybe more in lay terms, but the KV cache?
So the KV cache is basically storing the entire prompt. Okay. So it calculates all of the attention mechanisms so that it's able to say like, okay, I've taken this customer service routing flow, and now I'm going to generate that very first word. But it has to calculate that prefill, as it's called, before it can start the decode phase. So it's a prefill and a decode. So what we're saying is we're going to bypass the prefill because we've seen it once before. And we're just going to inject it immediately into the memory of the GPU so that all it needs to do is start the decode phase. Or only maybe just do like prefill the customer question part of it. You've already have everything else. And that actually speeds up significantly. We've seen 20x speed up for very, very long context windows that you're like, okay, instead of taking 10 seconds to get to that very first token, we can do it in less than 1.
Yeah. And it's not just one time that you're getting to that first token in 10 seconds.
You're doing this in agentic workflows over and over
again. So that becomes a significant speed up to the workflow.
There's also power savings because you're not using extra.
Yeah, you're extracting off the GPU usage and pulling power. This is where our fun analogy comes in.
Yeah,
right? This is where we get to Neo. So for folks, the program, very much the podcast over years has had lots of references to movies and things. Pop culture, usually the 80s, just because of my age, but The Matrix, right?
Well, I'm also from the 80s.
Yeah. Well, you look younger than I do, though, so I'm gonna give you that one. But Neo in The Matrix, right? It's just like, okay, I need to fight. Load in
Kung Fu.
Now I know Kung Fu, right? And there wasn't anything he had to learn or get taught. He just kind of knew Kung Fu.
And the reason why, and the analogy is applicable in several layers here, is because there was that knowledge already existed. That means that some GPU had computed a prefill before.
It had happened.
And now we can pass it to anywhere in the network, in this case, the Matrix, and saying anyone who wants to learn Kung Fu
doesn't have to. Neo, they could have gone to anybody who was connected, right?
I forgot the rest name.
I know, I don't remember. Which happens when we're our age. You forget names
Morpheus
of characters.
Is for sure
Morpheus, we would know. Yeah.
So that means that the entire fleet of GPUs, because it's on network attached storage, could now leverage this prefill that's already been calculated and inject that knowledge to anywhere in your fleet versus staying locally on that GPU node.
And I think the analogy helps, right? Because we'll have varying people, some are AI experts listening to this. Others may just want to kind of figure it out. So that gives a good understanding. What was the origin of this? How did, where was the aha moment or the engineering team or something where you guys looked to it? Or was it conversations with our alliance partners? I'm just curious. Like, how
this all
cool
came about actually through our VP of AI infrastructure, Parboats, who said like we should be working on this space. There are actually companies who do this, like there's software that helps us, but that's usually doing it in like a caching layer. Very few are actually at the storage layer itself. What we actually did that was novel was that we were the first ones to do it on object. So on KVA, you're able to do file, object, and then also like GPU direct support. So we could also pass that KV cache directly to the GPU and bypassing the CPU memory.
And then we've expanded this to other capabilities as well, right? Other protocols.
Yeah, we are
intending to. Yes.
Because we have a fleet of products at Pure Storage that can leverage all of this, depending on at the scale at which a customer might need it. But all of our products can actually use KVA.
Yeah, which is awesome. FlashBladey. FlashBladey kinds of things. What about the partnership relative to this, right? Because there is a connection into NVIDIA. with Dynamo, right?
Yeah, so NVIDIA came out with their architecture for how you do inference at scale. And what they've done, it's called the NVIDIA Dynamo. And what it does is that it separates GPU workers so that some of them are only doing prefills and some of them are only doing decode, so that you're able to do what's called speculative decoding, so that you can generate more tokens and then seeing what was the more optimal path. But you still need to pass the KV cache from the prefill to the decode worker node.
Okay.
So what we've done is we've integrated with Dynamo, where KVA is the mechanism that's actually passing the KV cache to the other decode, to the prefill node, to the decode node, while also storing that in storage so that it could be reproducible and held for long term. So when you run out of GPU memory, it's just going to kick out the last cache, or the first cache it had seen, so least recently used. But we can actually just say, like, it doesn't matter when you last saw this, as long as you still have that cache in storage, we can inject it very fast.
Okay, got it. Who's this useful for? I mean, is this
enterprise workloads?
Anything, whatever enterprise are trying to do.
Even ChatGPT and OpenAI, I should say, this is really OpenAI.
Yeah.
For their workloads, they're generally seeing about a 35% cache hit. And you can imagine the scale at
Huge
which,
scale.
Yeah, they process, like, I think it was 1 billion tokens a minute now. This is ridiculous. It's ridiculous.
Yeah.
But even then, they're still needing to leverage KV cache, because otherwise they wouldn't be able to process 1 billion tokens a minute. They'd be processing less because they first need to do the prefill.
Yeah.
So if OpenAI can do this, arguably probably better than anyone can, enterprises can take advantage of this fact that they're not seeing the variety of conversations that OpenAI does. What they're seeing is more business specific. So they might actually get more value, because what we ask about Pure Storage in our internal Slack communications channels isn't everything under the moon like OpenAI sees.
Yeah. No, it's far more vast what they're looking at and what they're covering. Makes sense.
Yeah. And there's a lot more benefits that other enterprises can have. And there's more things that we can do as well.
What's been the reaction? Like, we've floated this in front of users, customers, enterprises. Are they
love it?
Thrilled, blown away?
They love it. And we're seeing a lot of uptick. We're doing beta testing with a few customers at the moment and get feedback and make iterations just to make sure that it's ready for production.
Okay. And then once we get to that point, where and how do you take advantage of this? Or is this just, you use FlashBlade and
you use FlashBlade
at whatever layer of scale, as you mentioned, right? Even all the way up to Exa, I would assume.
Correct.
Right? Which gets really interesting.
Really interesting.
When you're talking about billions of things.
Yeah.
Right. That's kind of fun. And we've got another podcast with Hari coming out
sweet.
on. That one's coming out. I think it'll be debuting on the 17th of November with Hari on Exa, which will be kind of fun.
Yeah.
So we're hitting a lot of these fun things in and around supercomputing.
Mm-hmm.
We just did GTC DC,
Correct.
right? So a lot of excitement. It's very good timing. Anything final? Anything I missed as we were navigating through KVA?
Yeah. So one of the things that I missed was that we're also implementing S3 over RDMA. So what we mentioned, GPU Direct Support, or GDS. That's NFS over RDMA. But we're working and should be releasing in the next couple of weeks, by the time you're hearing this, S3 over RDMA. And we'll be testing KVA specifically with that, so that customers who really leverage Object Store can also take advantage of a GPU Direct system.
Super awesome.
Yeah.
Well, and huge congrats to, I think I understood through the planning of some of our Accelerate Roadshows that this was something largely developed by the engineering team in India. Right.
The S3 over RDMA,
or not the S3 RDMA, the KVA.
The KVA was actually done primarily by John Baptiste Thomas.
Okay.
Akash Bist in India, and then myself.
Okay.
So
you guys
just little three of us.
So it's a trio?
Three of us.
That's it?
With guidance from Par and a lot of late night sessions.
I assumed it was like
it was a small. So this is one of the things that I love about the work that I'm doing right now at Pure Storage, is that it's very much innovation led.
Yeah.
And in innovation, you can't have very large teams. You could have pockets of teams.
You get bogged down.
But you get bogged down. And the thing is, like, we want to go fast. And we were able to build KVA within 6 weeks to 2 months, depending on where you want to measure. We started. And the success of it has been incredible to see. That if we had tried to do this with former engineering processes, it would have been a little bit slower, and maybe it wouldn't have had the success that it had.
But that's the beauty of Pure Storage, right? And I've seen that in my almost 8 years here, right? Mm-hmm. There's just things that just come out quickly because provided it's approved and
Mhm.
and funded and budgeted, little teams can go off and do things. And it's kind of like that old adage, if you have a meeting with more than 5 people, you're never going to get anything done.
Yeah. Oh, yeah, I
And
know.
and similarly, we run kind of lean here at the Peer Report too. I mean, I don't know if people think there's a big team behind this, but I've always kept it to about 2 or 3 people to make sure we just keep it rolling.
Yeah. Rob's actually
So I-
pressing the buttons in the back and like
Yeah,
hitting
I've got
record.
buttons and I'm getting ready to do the editing on the fly. No, that's great. That's a good ad. Thanks for the background on that. I want to hit you into hot takes to
Mhm.
kind of close because you are AI guy,
Mhm.
AI guru, if you will. What do you think that companies are missing right now? What should leaders be looking at more? Is there a blind spot that's holding them back that you're passionate about or that you talk about frequently?
Yeah, I think there's gonna be when I think about company enterprise data, like it usually will reside on-prem. But that doesn't mean that you can't take advantage of cloud APIs
Okay.
to leverage the compute there or just to leverage the foundational models. So there's two things that I'll say about this. There are ways that you can keep your conversation history intact.
Mhm.
So that meaning that the user doesn't notice it, but what you're actually doing in the back is sending either that request through a local model for cheaper inferencing because what the customer is asking or what it's asking the LLM to do is fairly simple, and I'll use that in quotes. And then if it's saying like, hey, I want to do an actual really complex task, and you kind of know what the limitations of your on-prem models are, you could say, well, I can send this request now to a cloud provider and send it any relevant data that I need and take advantage of that really powerful model.
Okay.
And then we can integrate with tools like Comet or OPIC for LLM observability so that you can see all of those traces and seeing like, here's what you're saving by using these models. And then another use case is a lot of companies start in the cloud and start leveraging ChatGPT, which is great, but you're going to be paying per token.
Yeah.
And that's going to eat your cost. But so how do you then manage and make sure that as you go to on-prem, that you're getting the same results out? So we can use other tools and partner with other software providers to make sure that that transition from cloud to on-prem is seamless. And then there's other things we can do around Portworx, around like bursting to the cloud.
Right.
So I think as GPUs continue to be a supply chain issue, we will need to leverage hyperscalers,
Services that
are out there
Yeah.
to really take advantage of that because the field is moving so fast. As we joke in our team, our roadmaps are no more than 3 months out.
Yeah.
Because after that, we're like, I can't predict what's happening in month 4. Month 3, maybe I could see.
I sat in on one of your meetings 2 or 3 months ago, and the roadmap's like this, but then we're not sure after.
Yeah, we're like we know what we're going after
it's
right
not that
now.
you guys don't know what's going on, but things are just so capricious and so changing right now that you may make some assumptions about a year out, and then it's entirely different. But it's a great point on the cloud. It's kind of that old adage of right tool for the right job.
Mm-hmm.
But also, I think if you go back 10 or 15 years or so, you have those companies that are maybe born in the cloud because they're small and that's just what you do. But then you reach an inflection, you hit a tipping point where it's like, I need an enterprise database. I need enterprise apps, and we need to have, on-prem things. So
exactly.
you get to that point, we're seeing that happening with AI. Second question, this is always one of my favorite to hit people, and you've been a practitioner at times, or if it was a professor, I don't know, maybe there's a professor story. Any screw ups, memorable IT blunders or things? Did you pull a plug out of a rack, something like that?
I actually did find a security hole. I used to work at Intel,
Yeah,
and I did find a security loophole in our email messaging system that if you did it via like Python or R, like instead of like tie into the HTTP server via Python, that I can mimic anyone's address.
Oh my gosh! So you could spoof it. Well.
I could spoof it,
well.
And I literally sent a message to myself as the CEO to make sure it worked.
Oh wow!
And then my boss at the time, who I'm still very close with, I sent him a message as himself to him, and he's like, "Damn you, Robert!" Like I just remember like sending it to him and being at my desk, and 5 minutes later, I just hear Robert, and I knew exactly what it was. So.
Well, you're very clever. All right, that's an awesome one. That's a first. Really super cool. You found that. Last one. go back 10, 20 years, what do you wish you'd know? What would you have told the younger Robert, besides not to mess around in the email system? Well, that was probably very helpful
Yeah.
for the company. But what would you have told yourself to do differently, to learn more, to spend more time on? Like, what would
Yeah.
have stood out?
I would. This is more of a personal
That's
reflection.
all right.
I would have focused more on statistics. Not that I don't like. I have a PhD in mathematics. Like I know statistics, but knowing where the field is and where I ended up being, having that deeper statistical foundation, and understanding that that's truly how a lot of these algorithms work.
Yeah.
Deep learning, data science, etc., all have statistical underpinnings. That the math algorithms are fairly straightforward, but it's the statistics behind them that make these problems even more
The
difficult.
predictive elements, all about that, right? Yeah.
And so I would have focused more on statistics, and I've never called myself a software engineer. I've always been a prototyper at best.
Okay.
My code doesn't go into production, but I think I still would have focused more on the statistics side.
Okay. More statistics and maybe dabbling in software engineering a little bit, do a little more coding, or not your thing. Yeah. Okay.
Not my thing, but the business use cases for sure is something so going back to my time as a professor, I actually taught at the business school at Santa Clara University.
Okay.
At the Levy School of Business.
I went to the Levy School of Business. I
Okay.
did. Yes.
So they have a master's in analytics program, and I taught data science and machine learning there.
Okay.
And most of my students were either from the MBA program or had more business backgrounds. And I always told them, like, look, I'm going to show you how the algorithm works, but ultimately, like, you need to know how to communicate what the algorithm does. And I would always give these analogies. And I think that also forced me to think more translational instead of giving them like the nitty gritty of like, here's the math behind your algorithm. It's more of like, here's how the algorithm works in a way to communicate to others, because you're going to be product managers, you're going to be business leaders, you're not going to be engineers.
Yeah.
And I think that's actually helped me tremendously in my career. So for those who are unsure of like where to go next, communication is vital in an enterprise organization. If you're the one who could communicate ideas of why things are important or why things are not important, you'll pave your own way.
Yeah, I kind of tell that to high school students that I meet with and speak with about business, and some of the college interns that I talk to as well, when they go, do I need to have good presentation skills and be able to communicate? Like, I'm just going to be an engineer, I'm going to code or whatever. And I go, no, like every job you have requires you at some point to get in a room with 5 or more people and to talk about your idea or try to convince people that it's something you should do. You should have good communication skills and also be able to present. So it's a good thing.
Yeah.
That's awesome. Hey, this was a lot of fun.
Likewise.
Thanks for coming on.
Of
And
course.
super exciting for everybody. Pure KVA, as Robert said, still working with some customers on it and then getting ready to get it rolled out. But we've gone public announcing it, right? All the details are out there, and it's super exciting and part of a lot of the AI innovation that we have going on here.
Yeah.
I'm excited to see what's next.
Likewise.
Awesome. Well, thank you for coming on. Thank you, everybody, for checking out this episode. If you want to learn more about Pure KVA, go to Pure Storage and do a quick search on the blog. There's a blog.purestorage.com. There's a KVA blog that is great. And of course, we covered it in one of the recent launches. So purestorage.com/launch is where you will want to go to learn more about this. And if you want to find this gentleman, you can find him on LinkedIn and go write him a comment about whether you like or dislike pineapple on your pizza. Thank you so much for watching and listening to this episode. Share with friends, share with a colleague, and we will keep the great guests like Rob coming on to the program. With that, we will wrap for Pure Storage. Robert Alvarez, this is Rob Ludeman saying, don't look back. Something might be gaining on you.
Nice. Oh, great. This was fun. I love these. These are so much easier to do.